Good evening, everyone. My name is Aditi, and I am the presenter for this presentation. Welcome to my Ortelius Microservice Visionaries 2021. So, the topic for today's talk is implementing a microservice architecture using domain-driven design. Before we jump on straight away to the topic, let me introduce myself. My name is Aditi Agarwal, and I am currently pursuing my graduation in computer science. Currently, I'm doing an internship at Cisco as site reliability engineer, and I have interest in open source community, which is one of the reason I got connected to this Ortelius community. You can connect me at my various social handles, Twitter, LinkedIn, and GitHub profile. All right. So before I introduce you what is Ortelius open source, whatever it is written here, I would like to make you familiarize with the topic which we are going to discuss today. So in this session, we will define why a domain-driven design is important to building a shared service architecture and demonstrate how Ortelius helps facilitate this methodology through domains. So Ortelius is a basically open source community which provides the facilities in the microservices world. It is a microservice management platform. So before I go deep down, what does it do and what are these various terms, versions and tracks microservices, I would like to introduce you the whole concept of the microservices. Where did it come from? What was the need of it? So let's get started. So the days when we did not use much microservices architecture or microservices term, when we were stick to the monolithic architecture. Monolithic architecture is basically a traditional architectural style in which we build our application as a single unit. And it is also scalable, but in terms of scaling, I can say it is more resource occupying. For example, let's take the e-commerce application example. We have a sale going on live in our application, and customers are heading on to my catalog service very often. They are trying to see what are the products I am offering to them, what is the sale, what are the prices, and so on. So my catalog service is having more traffic than my order and the payment service. So in order to serve more and more customers, I need to scale my application for the catalog service only. But in case of monolithic architecture, since it is a single unit of application built in a single bar or jar file, we cannot scale a single unit of service. We have to scale the whole application together. We cannot scale any individual service. So in that case, it becomes more resource occupying, though we do not need more scaling for the order and payment service, but yet we have to because we do not have any other option. So that becomes a major disadvantage of the monolithic architecture. So moving on to the microservice structure. Now let's see what is microservice architecture. So what are microservices? Microservices are small and autonomous services that are built together, that work together. What is autonomous? Autonomous is something which is self-governed, which takes care of its own. We do not have to really intervene into the whole functionality of it or anything. So in the microservice architecture, we can say the microservices are loosely coupled with each other. Loosely coupled in the sense when you have a service which is independent of its own, which is not depending on any other services for its functionality, and we can make changes to that services and it will not be affected by any other services. Microservices key component is that it is reusable. What is the advantage of making an architecture which cannot reuse its functionalities whenever needed? Why do we have to create and deploy the microservices again and again when we can just create a one microservice and can be reused in multiple other services? So microservices are reusable and recomposable. We can create a microservice for a specific function, and in case if our another application needs the same functionality, we can reuse that microservice. Now the topic is domain-driven design. So to implement microservice architecture, we need a kind of design to be made. So domain-driven design helps us to categorize and share our microservices across teams. Since our microservices are built by small teams, so it is much easier to share those microservices among different teams so that they can reuse them and recompose them. And also we see our organization in terms of problem and solution spaces. So domain-driven design basically divides our organization into two spaces, that is problem space and solution space. As in the picture we can see, there is a problem space and there is a solution space. So firstly, using the problem space, we try to understand the problem to which the solution will be provided using domain-driven design. So in case of problem space, we have two terminologies. One is domain and second is subdomains. So domain can be taken as our whole organization, that this is the problem domain which we are having, and for this problem domain we will be proposing a solution space. So problem space, which looks specifically at the business architecture, it does not go deep dive into the software thing. So we firstly make a roadmap of our problem, that this is the specific problem, this is the use case which we have to implement, and using this use case we have to develop a solution in corresponding to that. So solution space is something which we design according to our problem space. In the solution space, we have a term called bounded context. Bounded context is a boundary within which our solution lies. Here we talk about the software architecture. Like in the case of problem space, we were talking about the business architecture. In the solution space, we relate that with the software architecture. And it is also linked to the business for serving the problem space. So solution space has few terminologies, that is bounded context, domain models, ubiquitous language, and context maps. So let's try to understand these. So here in the left picture, as we can see, let us try to visualize the problem space using this picture. For example, I have this complete picture as my domain. Let's take my organization name is XYZ. So my domain name is XYZ, and in my domain I have these two subdomains, which is warehouse and finance. So in this case, I have two subdomains, warehouse and finance, in which I have a few solutions which need to be implemented. So if we see this from the perspective of the problem space, the complete organization is something which is called domain, and inside that, how many subdomains or the departments we have, that can be termed as subdomains. So now if we try to look at it with the perspective of solution space, then how can we look at it? We have this complete context, which can be referred to as a context map, inside which we have these two contexts which can be used or termed as bounded context. For example, my finance department is a bounded context which has a boundary of finance department only. Inside this bounded context, I have my own ubiquitous language and I have my own domain model. So what is a domain model? Domain model is basically implemented within its bounded context. For example, we have a whole domain model, or we design a domain model for our finance bounded context. And the language or the communication using which we design a model, that is called ubiquitous language. Ubiquitous language is something like the common communication that we can have with the client and as a developer. For example, I am the developer and I have a client which has given me a problem space according to which I have to develop the solution space. So I must be using a common ubiquitous language, a common communication language which can be understood by me as well as my client. Since my client would not be so much technical, so he or she would not be able to understand all the technical terms. And even I am not much that business consultant, so I might not have the knowledge of those business terms. So we must have a common communication which we both are able to understand and get that. So for that purpose, we use ubiquitous language, which is constrained in a bounded context only. Each bounded context has its own domain model, and that domain model is created using a common ubiquitous language. Okay. So this is a whole view of this, and inside, and since we have these two bounded contexts inside this whole context, so context map is something which tells us about the overall picture of our complete domain. For example, this complete picture has two bounded contexts, so my context map is having two bounded contexts right now. But as it is said that the more smaller and the easier the picture should be, it will be more easy to understand. So in the terms of domain driven design, it is said the bounded context should be kept as small and as easy to understand as possible. So we can further segregate or nest our bounded context into these terminologies. For example, I have this warehouse which I told you about as a whole bounded context. But to understand it in a more convenient way and to handle it as a more granular approach, I can further create bounded context of all these components as well. For example, instead of treating warehouse as a whole bounded context, I treat trolley as a separate bounded context, picker as separate, picking order as separate, and so on. So here you can see that then this trolley, this picker, this picking order, each one of these will have their own ubiquitous language and their own domain model. So what is the advantage of this? So in the domain driven design, it is expected and it is advised to have smallest bounded context as possible so as to make more easier and convenient microservices, because inside this whole bounded context, if I take into picture, I have to create multiple microservices, and I have to take into consideration a ubiquitous language which can be understood by the stock report, company valuation, and general ledger, all of these three things. So what if I create a bounded context of stock report only? Then I do not have to include general ledger and the company valuation in it. Then that would be more easy for me to understand and for client to understand. So that is the whole picture of the domain driven design, to segregate the bounded context into a small entity so that it becomes easier for us to develop the microservices. And also here we can see that it is a shared model. For example, I have a bounded context stock item, and inside this stock item, I am implementing this stock item. So it can be shared to another bounded context, that is finance, and this microservice can be reused by this bounded context. So here we can also see the reusability of the microservices. I hope you get a broader view of domain driven design till now, which is designed using domain driven design. We have three layers which are independent for each microservice. So as I have already discussed, that aim should be to keep microservice bounded context relatively small. So it is more easy to design a bounded context which is comparatively small. And the layer design which should be independent for each microservices are these. Each microservice has three layers, that is application layer, domain model layer, and infrastructure layer. So what is domain model layer? Domain model layer is the heart of business software. It is responsible for tracking all the data and the behavior of our service. It is something like we have a service which is designed as a class library, and inside that class library we already have defined all the methods and logic which are need to be performed. It basically drives the other two layers, that is the application and the infrastructure layer. So what is application layer? Application layer basically tells what is the job that exactly needs to be done. For example, I have a web API interface. I need to create a front end for my application. So that thing my application layer will decide. And the infrastructure layer is responsible for keeping the data to its database, persistent data. Basically, until now we have all the data in our memory. So now we need to keep them in a persistent storage using any database or any persistent store. So infrastructure layer will basically connect my front-end application or my application layer to a persistent storage. For example, a storage engine. Whenever we go to Google or we go to any searching engine, we type a data which we need to see or we need to get. So from where does it fetch the data? It also fetches the data from its persistent storage. So that is the role of infrastructure layer. Now, if we see that dependencies between layers, what are the dependencies between these three layers? Then we can clearly see that domain model layer is irrespective. It is not dependable on any of the two layers. Since it is the heart of the domain and it is the heart of the business software, it does not depend on any of the layer. It is only responsible for implementing the domain entities, aggregate, roots, and value objects. While application layer is something which is dependent on both domain model layer and the infrastructure layer. Domain model layer has to be dependable because application layer, after all, has to be dependent on domain model layer because it is the heart of the software, and domain model layer needs to know about all the app layers that are implemented in the microservice design. And also application layer is dependent on infrastructure layer because after all we designed a backend, we design a front end of our application, so from where it will fetch the data. So that is the place where our database hides. So our database resides in infrastructure layer, so application layer has to be dependent on the infrastructure layer. And we can see that infrastructure layer is only dependent on the domain model layer. So it does not need to be dependent on the application layer because it is responsible for only residing the persistent data. So our infrastructure layer is dependent on domain model layer, which keeps the record of the infrastructure layer as well. So now, since we have discussed microservice architecture, domain-driven design, and the microservice architecture using domain-driven design. So now we all must be thinking to shift to microservices. So how to shift to microservices, how to actually manage our microservices architecture, how to actually use our whole architecture in terms of microservices. So there arises the need of microservice configuration management platform. I know it's quite a long term to understand, but if we break down into small parts, then we can see microservice is something which is a topic, and configuration management platform is something which provides us to manage this complete context. So I hope now you would be able to get this, what this line actually means, that it is a microservice management platform which is actually responsible for versioning and tracking the microservices, and other functionalities like blast radius, inventory across clusters, providing a proactive view of your microservice architecture as it changes over time. And Ortelius is a project which is under the governance of the CD Foundation and which comes under the Linux Foundation. Our mission at Ortelius is to simplify the adoption of microservices through a world-class microservice management platform. So, so what does Ortelius do exactly? Ortelius helps us to visualize all the microservices we have in our application, all the versions of the microservices we have in our application. We can track the microservices, whether if any microservice is down or anything is breaking up there, and we can also share microservices across the clusters. And Ortelius is also built upon domain-driven design, which we have already talked about, which was the key reason for making it easier to share and organize microservices across teams. So for understanding the concept of domains in Ortelius, we have something called Ortelius Domain Catalog. As from the picture we can see, this is the dashboard of the Ortelius, and inside which we have a section called domains. So this is the domain catalog inside the Ortelius, and this domain catalog is designed to make microservices publishing, sharing, and easy. So microservices, we use the microservices. So how do we publish them? Where do we publish them? And how do we aware the developers that our microservices has been published? And how do the developers actually get to see where are these published? And how can they share these microservices inside their applications? So all these things can be done inside the domain catalog of the Ortelius. Developers can consume these microservices without actually creating their own deployment logic. As I have already talked about the reuse functionality of the microservices, so Ortelius provides us this functionality that we can actually consume the pre-created microservices if they serve our application as well. We do not have to really create microservice again and again. So it also provides microservice versioning solution, informs about the new version to all the linked applications. For example, if I have an application which is currently using 3 microservices and one of the microservice needs to get updated to a new version. So that application will be informed as soon as my microservice gets updated, and it will be linked to the new version of the application of the microservice, not the old version. Similarly, if that microservice is used by any other application, then that application will also be informed. So this is the whole picture of the OTDS. It follows a top-to-down structure in domain catalog. As in the picture, you can see that this is the global domain, that is the whole organization domain, which is further divided into subdomains. These are all the subdomains which are coming under my whole parent domain. So Ortelius domains, there are various types of Ortelius domains in our Ortelius. First one is site domain. So this is the highest level of domain which I am talking about. So like this, we can see here the global term written here. So this is the site domain, the highest level of domain and the default domain. So in Ortelius, we provide two types of functionalities. One is for the SaaS users. Our Ortelius product can be used by software, can be used as software as a service and also as on-prem tool. So for the SaaS users, this site domain is defaulted to the company name. So we can rename your site domain if needed. And in the case of on-premise installation, the default site domain named is global. So I am currently using the on-prem version. So in my case, it is showing the global name, but I can also change that if I need. So anything defined to this level can be shared across lower level subdomains. So whatever the functionalities or events or environments and tasks I have at this level of domain, that can be inherited and used by all of the subdomains which I have further. For example, environment and task defined to the site domain are shared by all the child subdomains. Next, we have catalog subdomains. These domains are used to organize reusable components such as microservices. So inside catalog domains, we publish our microservices, and at this level, we can create as many subdomains as we need to represent our company or our component organization based on the solution space. So basically, according to the organization and according to the problem space of our organization, we can create a catalog subdomain which will publish our microservices according to the solution space we need. For example, security services, purchase processing, data access, ad services, these are all the subdomains which I have inside my site domain. A catalog domain does not contain lifecycle domains. So I'll explain this later on. Project subdomains. So next we have a subdomain called project subdomains. So what is project subdomain? This is a subdomain to represent your software application and its lifecycle. So initially we talked about catalog subdomain and site domain, which can together be taken as a problem space part. So like in the case of problem space, we had domain and subdomains. So from the picture of Ortelius, we can convey that site domain is something which resembles the whole domain. Catalog subdomains is something which further divides that domain into subdomains. And then project domains is something which will be actually responsible for creating our software application and its life cycle. Project subdomain is serve also as the parent domain for our lifecycle domain. A subdomain defined for any application may need a continuous delivery lifecycle. So whenever we create any software application, that software application will be having its own lifecycle. So from the time it is created, from the time it is being tested, from the time it is being deployed, and any versioning if has to be there. So everything is included in that continuous delivery life cycle. So to define this thing, we need to select all subdomains are life cycle, which is an option there when we create a subdomain, then it has. So if we check this option, then then we are justifying that my project subdomains will also be my lifecycle domains. So this means that any subdomain cannot include any additional subdomains and will be used to represent stages of the pipeline with specific environments assigned. So this will clearly means that now you cannot create any further subdomains for this project. This project will be considered as the complete lifecycle for your software application. So any versioning if you have to do and any updates if you have to do, then you will be doing in this subdomain only. You cannot create any other additional subdomain. So the child domain of this project domain is lifecycle subdomain. It is the lowest level of subdomain. It is available when you have the parent domain project subdomain and which is tagged as all subdomains are lifecycle. I'll be showing you this point in the demonstration of the Ortelius. These subdomains map to each stage in continuous delivery pipeline. So when we declare a continuous delivery pipeline, these subdomains represent a single stage of your life cycle. So at which stage your subdomain is basically, whether you have it in the development stage, you have it in the testing stage, or you have it in the production stage. They often have specific environments and tasks assigned for interaction with your continuous delivery orchestration engine. So if we have to differentiate it from the other subdomains, we usually have tags attached to it. So that makes easier to identify the different kinds of subdomains. So those tags can be attached in the form of environment that we are using, like production, testing, or development, or any of the tasks which has to be assigned. For example, we have to generate this request to this subdomain and we have to generate that request to another subdomain. So that is also a point of differentiation between the two. And Ortelius can also be called by your continuous delivery engine. For example, Jenkins, Jenkins X, Circle CI, Google Cloud Build, GitLab, GitHub Actions. So any of the continuous delivery engine which you are using in your organization is supported by Ortelius as well. Getting a broader picture of view of Ortelius domains, as we can see in this picture, we have an online store company called Hipster Store, which has its domain. So in the case of on-prem, we'll see the global domain, but in the case of your organization, you'll see your company's name. So for example, we have here Hipster Store domain. Here we have different microservices. For example, I have a front-end microservice which will be responsible for the front-end application of my complete microservice architecture. And this domain is further divided into two subdomains, that is the purchase processing domain and the store services domain. And these two services have their further subdomains. That is, purchase processing contains shipping microservice, payment microservice, currency microservice, and checkout microservice. And store service domain also has product catalog, ad service, cart service, and email service. So all these subdomains are categorized into my hipster application with components. So using the project domain, project subdomain we can see all these microservices which are there in the subdomains. So as we can see, now we have these 7 microservices as a whole in my application. And we can also see a picture of the hipster environments that we have. So that if we have to differentiate a lifecycle domain from another lifecycle domain, we can attach these environments to them. So right now we have 4 environments: dev environment, system test environment, and prod environment. So this is a whole broader picture of the Ortelius with its domain, its subdomains, its environments, its application with components. All right. So now let's go on to the demonstration of the Ortelius domain catalog. So this is the Ortelius dashboard. If we see, here I am logging in to my Ortelius dashboard. This is the on-prem version of the Ortelius dashboard, and this is the domain section as we see. So this is the domain catalog of the Ortelius. This is the sunburst map which I was talking about, which resembles all the domains which I am having in my Ortelius dashboard. This is the global domain. Since I have on-prem version of the Ortelius, then I am having this global domain, which is further divided into multiple subdomains. For example, this project one, my pipeline, and so on. These are all the subdomains. And inside these subdomains, I have further domains, further subdomains, which can be considered as my project domains. So this is the development project, this is the testing project, this is the integration project, and so on. So if we want to see the details of this application or this domain, we can get a picture of it. Full domain, my complete domain name is global domain. Currently, I am under my global domain section, so it is showing the full domain as global. And we also have the facility of giving the access of the owner as admin or subdomains, which are listed out here. And then we have access control thing, which is something. So what are the access controls for my these domains? Who can see it? Who can change it? Who can read it? Who can write it? So these things are there. If I go beyond, for example, I'm going to my pipeline. Now my pipeline, this is something which I have. So now you can see that my details also changed. My full domain remains the global, but my name changed to my pipeline. Earlier it was global, now it is my pipeline. Now we can see that the host name has also been changed. Earlier it was deployment engine, now it is our proxy. Now we have further subdomains inside it, that is development, testing, integration, production. So these are all the details for this. If I go beyond, then we can see again these details get changed. Now my full domain changed to global.mypipeline. So this is the thing to note, that all the domains in Ortelius are resembled as objects. And these objects are resembled as domain which are distinguished by a period. For example, global is my global domain, the parent domain, foremost parent domain, and my pipeline is the subdomain inside my global. And development is a further subdomain inside my pipeline subdomain. So this is the hierarchy of the domains in Ortelius. And if I want to go back to the global domain, then by just clicking it, I can go to that global domain. So this is the overall view of the Ortelius dashboards and the domain catalog in Ortelius dashboard. So that was all about today's talk. I hope you have got much information about the Ortelius monolithic microservice domain-driven design. You can follow and get more information about Ortelius on their website, their GitHub, and you can also follow Ortelius on LinkedIn and Twitter as well. Thank you very much.